So we're going to talk about how to actually run the hypothesis test in 7.2. Now, you already know what the decision rule is. We find the p-value and we compare it to what? Oh, come on. The alpha, which is the level of significance, right? As long as p is less than or equal to alpha, what do? Reject the null hypothesis. If it's greater than alpha, you fail to reject the null hypothesis. So let's just look at making that comparison. Yes, let me back up so you can see it. Okay. Okay. So let's look at this and see if we can decide what we should do if we have this as a p-value and we want to compare it to this level of significance. All right, so I'm going to compare p to alpha. My p is 0.0237. My alpha is 0.05. Which one's bigger? The alpha is bigger. So p is less than alpha. If p is less than alpha, what is my decision? There you go. I'm going to reject what? What am I rejecting? When I run this test, I'm always testing which hypothesis? The null. I reject the null hypothesis. Okay, now let's try it if we change our level of significance to 0.01. So if the p is 0.01 and the alpha is 0.05, did that make any, oh, sorry, I put the wrong, let me back up. That's not what I wanted to do. The p has not changed. It is 0.0237. It's the alpha that has changed, and the alpha is now 0.01. Which one is bigger here? P is larger than alpha, and if p is greater than alpha, what's my decision? Fail to reject the null hypothesis. Okay. All right. So after you determine the hypothesis test standard test statistic and the test statistics corresponding area, you do one of the following to find the p-value. If it's a left-tailed test, all we're looking for is the area in the left tail. That's going to be my p-value. If it's a right-tailed test, I'm looking for the area in the right tail. If it's two-tailed, it's got to be 2 times the area of one tail, okay? The area that's in one tail. All right, find the p-value for a left-tailed hypothesis test that has this test statistic. Z is equal to a negative 2.23. We're going to decide whether to reject the null hypothesis if the level of significance is 0.01. So let's do this together. My p-value for a left-tailed hypothesis test. What should I do? When I see left-tailed hypothesis test, I should do what? Draw a left-tailed region with this bell-shaped curve, right? Now, it didn't tell me what the p-value is for that shaded region, but it did give me the z-score that goes with it. Z is equal to what? Negative 2.23. Now, how could I find the probability that I would have area in what the area is in this region? The probability being in this region or the area of this region, if that's my z-score. What does that sound like I might use? That sounds like I could use a normal CDF. So if I did a normal CDF, okay, I would go into second bars. I would choose normal CDF. I'm going to leave that lower value like it is because I'm way out in the left tail. What would I put in for the upper value? Negative 2.23. My mean is what? If it's a Z-score, the mean is 0 and the standard deviation is 1. Okay. What is my p-value? 0.013 if I go 3 places. My alpha is 0.01. Now, if I'm doing a comparison, which one of these is larger? P. 0.013 is bigger than 0.010, right? And if P is greater than alpha, what is going to be my decision? Say it again. I will fail to reject the what? The null hypothesis. Okay? That's not too hard, right? There's another way you can do this. Let me show you. Yes, I've been waiting on this. Okay, here's what else you can do. Let's go back into stat and let's go to tests. And when we wanted to have that confidence interval, we went down to number 7, which was the Z interval. Look at test number 1. That's a Z test. Okay? Now, here's how this is going to work. I'm going to be putting in stats. What will be my mean? Oh, actually, you know what? Never mind. We're not ready to do this yet. I'm jumping ahead of the gun. Sorry. We'll get there in a minute. We're going to be doing a Z test. But for now, I would use a normal CDF to get the area for this region, and that's your p-value that you compare with your alpha. Now, how about this guy? Find the p-value for a two-tailed hypothesis test with a test statistic of Z equals 2.14. And then we're going to use a level of significance of 0.05. Shall we sketch another normal curve? That was a yes, right? And what kind of test is this one? It's two-tailed, isn't it? So doesn't that mean that I have area in both of these tails? And it tells me that my test statistic is Z equals 2.14. Now, how am I going to figure out my Z value? Or not my Z value, my P value? If you don't want to do a normal CDF, could we use the table? Absolutely. Now, I want to be careful though. If I'm going to look this thing up in the table, since this is two-tailed, do I actually know what the Z value is here? It's got to be what? A negative 2.14. And that would mean that since the table gives me area to the left, that's probably the easiest way for me to get it out of the table. I could look up a Z-score of negative 2.14, and that looks like 0.0162. Okay, so this would be an area of 0.0162, but be careful. Is that my p-value? I've got to multiply it times 2 because I've got that much area in this tail as well. So P is going to equal 2 times 0.0162, which is how much? .0162 times 2 is 0.0324. And that's got to be compared with alpha. And what did they tell me to use for alpha? 0.05. Which one of these is bigger? Alpha is bigger. So if P is less than alpha, what's my decision? Say it one more time. There you go. Reject the null hypothesis. Okay, does that make sense? Let's go back. Pick up the slideshow. We'll just verify we've done everything right. All right. So on our first one, we did get 0.0. Well, they left 4 places. We rounded to 0.013. That was more than enough to see that it was actually greater than 0.01. So we failed to reject. On this one, they came up with 0.0162. They found that for the right tail, but that's the same thing we found in the left tail. So when you multiplied it times 2, you got 0.0324, which was less than 0.05, and therefore you reject the null hypothesis. Now, the z-test for a mean, mu, can be used when the population's normal and you know the standard deviation for the population, or when's the other case? As long as your sample size is, there you go. It keeps coming back, doesn't it? As long as the sample size is 30, you don't have to worry about anything. If it's not 30, you just have to make sure the original population is normal. Now, your test statistic is the sample mean x bar. The standardized test statistic is z. So this is the formula that you would use to convert that x bar into a z-score if you're going to use the table. All right, and remember, you have to adjust the population standard deviation based on your sample size. So as long as n is greater than or equal to 30, if they didn't tell you the population standard deviation, you're allowed to use the sample standard deviation for the population. You still divide it by the square root of n though, okay? Now this is just kind of summarizing all the different pieces we've talked about, but let's look at how we're going to put this together to actually run a hypothesis test using p-values. All right, auto racing. Any NASCAR fans? No, okay. I am not a NASCAR fan, but I have to admit I marvel at the way things work at a pit stop. I mean, have you ever seen people change a tire so fast? It's just mind-boggling. So a pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. Yeah, I know, crazy. A random selection of 32 pit stop times has a sample mean of 12.9 seconds and a standard deviation of 0.19 seconds. Is there enough evidence to support the claim at an alpha level of 0.01? Now, what would you think? Can we do this? You're supposed to say yes. Okay, let's try. So we're going to go through the whole shebang. Hypothesis test start to finish. What's the first thing we need to try to do? Well, I don't want to draw a graph just yet. Remember at the very beginning, I need to state to what? Yeah, I've got to be able to translate the claim and decide which hypothesis it is, null or alternative, and then I'll get the complement to be the other one. So what do you think the claim is? Okay, the claim is that their mean pit stop time is less than 13 seconds. Now, which hypothesis is that? That's your HA. And the reason you know that is why? There's no or equal to. Very good. So what does that mean that my HO needs to be? It would be greater than or equal to, because the two together have to cover every possible case. So I've written my 2 hypothesis statements. I now have the claim. And then you had mentioned we could sketch this thing out, right? And we would then be able to put all this stuff on here. This is, I think, the part where you're ready to meet your friend, Mr. Calculator, okay? So I had mentioned if you go to stat and you go to tests and we go to z-test, here's what we're going to put in. What is going in for the mean is going to be the value that you see in the null hypothesis. The mean is what? It's stat, go to tests, and choose the number 1. It'll be the z-test. Well, look at your statement. What is in the null hypothesis? What number? 13. That is what you put in for your mu. Now, your sigma comes from what the standard deviation is in the problem. It looks like it's 0.19. Your x bar is what their sample mean was, and it's how much? 12.9. How many are in our sample? 32. That's my n. Now, look at what's coming up. You have to choose what kind of test you're running. That's based on looking at what? The alternative hypothesis. So what kind of test would this be? Do I choose this one, or this one, or that one? Which one do I need? The middle one, the one that's less than. So that's the kind of test that I'm going to run. I just match the symbol that's in the alternative hypothesis. Arrow down to calculate, hit enter, and look at all this information it tells you, okay? This is telling us if we wanted to look up the z-score, because maybe we wanted to actually find the area using the table, it'll tell you what the z-score is. It gives us P. I don't need the table if I use this. And then I can run my test. So according to the z-test, here's what I found. P is 0.0015. Agreed?
Yes.
Okay. If I had been doing it the other way, I would have sketched my graph. I would have put a mean of 13. I would have done my standard deviation for the sample means as 0.19 divided by the square root of 32. And I would have put 12.9 over here to figure out what that area is and done a normal CDF. Or I would have converted it to a z-score and gone to the table. I can still do it this way. That's just a lot more work than doing it this way. Agreed? Yeah. Now, I haven't finished the test yet. I just used the z-test, which, by the way, if you do it in the calculator, that's what I want you to do, is tell me you did a z-test. And this was the p-value you got. We're going to compare it to what alpha value? 0.01. Which one's bigger? So if P is less than alpha, what does that tell me to do? I'm going to reject the null hypothesis. Now, remember, the last thing I have to do is make a statement about the claim. So the claim showed up in which one? The null hypothesis or the alternative? The alternative. So what do you do with a ha? You support it. So tell me how to word this statement. Either there is or there is not enough evidence. There is enough evidence to support the claim that the mean pit stop time is less than 13 seconds. I'm going to go ahead and write the whole thing out. And I'm going to add one more little piece here that we have not done now that we're putting the whole thing together. It would be a good idea to include what you used for a level of significance. Because remember, we said that level of significance kind of determines how much wiggle room you have. So if we're going to make this claim, we really ought to say at what level of significance. And we used what? Yeah, so if you said at the 0.01 level of significance, there is enough evidence to support the claim. that the mean pit stop is less than 13 seconds. You've got everything you would need written down there. Does that make sense? Now, before you get too overwhelmed or stressed, on the test, there is one problem that is a whole shebang like this. Start to finish, you got to do the whole thing. And it would basically be considered like extra credit. You're going to see more questions that it may just be state the null hypothesis, state the alternative hypothesis. It may ask you to find the p-value and just compare it to the level of significance. You know what I'm talking about, where it's just pieces of the hypothesis testing as opposed to the whole thing. So if you're concerned that you're going to have a hard time remembering how to keep all of it straight, that's not going to be what most of this test is. That's one question, okay? So don't freak out. Okay, so let's go back to the PowerPoint. And this is what it would look like doing it the old school way. You would have gotten a z-value of negative 2.98, which you would have looked on the chart, which would have given you a p-value of 0.0014. We got 0.0015. That's still close enough to easily make the call that p was less than alpha. And at the 1% level of significance, we have sufficient evidence to support the claim. Okay? Let's try another one. The National Institute of Diabetes and Digestive and Kidney Diseases reports that the average cost of bariatric, which is weight loss surgery, is $22,500. You think this information is incorrect. You randomly select 30 bariatric surgery patients. Find the average cost for their surgery is this amount with a standard deviation of that amount. Is there enough evidence to support your claim at an alpha level of 0.05? And again, we're going to use the p-value to compare with our alpha. Okay, you guys know what to do? Where do we start? Okay, we got to be able to translate the claim and then get our two statements. So what do you think the claim is?
The average cost is $22,500 equal to 20.
Well, does it say that it costs less, or does it just say that we think it's incorrect?
Oh.
Okay, so this is going to end up with a not equal to. So if the mean is how much? 22,500. Then the null hypothesis is going to be what? That it's not equal to 22,500. Okay, so I'm sorry, go ahead. This is going to make it a two-tailed test. Very good. Now, which one of these is actually the claim, you think?
No.
No. Well, let's put it this way. It says you think the information is incorrect. That's your claim, okay? Wouldn't you say? But this is the data they reported, all right? So we're saying we don't think it's right. This is the data that's reported. And you guys have said this is a two-tailed test.
So in this situation, it'll be our claim?
We're testing our own claim.
Well, your claim is that their information is incorrect. So we're running the test to see whether we can support that claim or whether we can't support that claim, okay? Now, are we wanting to do it this way? Of course, okay. So tell me where to go. Do you remember? Stat tests. Which one? Very good, a z-test. Okay. What would we put in for the mean on this question? 22,500. What would I need to put in for sigma? Which, by the way, I didn't ask you this. Did you see normally distributed anywhere? But there's 30, so we're good. Okay, so what would we put in for sigma? 3,015. What would be the X bar? There you go. That would be the average cost in the sample, which was 21,545. And you said there's how many in the sample? 30. Okay, and what kind of test is it? First one, two-tailed. Very good. Okay, now we're going to calculate. And I'm coming up with what for a p-value?
0.083.
Now, don't forget, that's the value of p in how many tails?
2.
This is only the value in one tail, but I will need to do what to get the value in two tails? Times 2. So p is equal to 0.0828 times 2, which means I get what? 0.1656. And I'm going to compare that to an alpha of what?
0.05.
Okay, that's not very similar, is it? No, those really aren't even close. For sure, what's bigger? The p is greater than the alpha. So if the p is greater than the alpha, what's going to be my decision? If p is greater than alpha, okay. Yeah, the decision about the null hypothesis, if p is great, now remember, this is what we're checking to see. I got to compare the p-value to the alpha. Look at what we did on the one prior to this one. We got a p-value, oh, where did I put it? We got a p-value that was 0.0015, and when you compared it to 0.01, obviously p was smaller. And if p was less than alpha, our decision was to what? Reject. As long as p is smaller than alpha, you're going to reject. But this one, p is definitely bigger than alpha. So what does that mean that I do? I fail to reject the what? Is it the claim or is it the null hypothesis? My test is always to see whether to reject or fail to reject the null hypothesis. After I decide that, then I make the statement about the claim. Okay, is that helping a little bit? You getting more of the pieces? Okay, so this is where you got to be careful you don't get ahead of yourself, because you got to do it step by step. You're going to have to make sure that you get down your statements correctly for your hypothesis, your null hypothesis, and your alternative. Then you'll have to figure out which kind of test you're running. If it's one-tailed, two-tailed, and if it's one-tailed, is it right or left? But that comes from looking at which statement. The symbol in, is it the null or the alternative hypothesis, tells you what kind of test you're running. The alternative hypothesis. And then, if you sketch it out, you're ready to go to stat tests, and you can do the z-test, which is what we're doing here. But you do have to be careful. If it's a two-tailed test, you've got to remember that this p-value that I'm getting is going to be, oh, actually, you know what?
One would think that since you select the two-tailed test, why does it make you multiply it?
That's, you know what? I take that back. It actually does adjust it for us in the calculator. If we were finding it out of the table, we've got to double it. Now, is that going to affect our answer here if we're just using 0.083? I'm sorry. If it comes out of the table, remember you only found one tail, you double it. If you are using the calculator, because of the two-tailed test feature, it did double it for you. Thank you for saying that, Robbie. Okay, sorry, it's Wednesday night and I'm tired. My brain is kind of fried. So at 0.083, is it still bigger than 0.05? Definitely. So it didn't change our ultimate decision that because P was bigger than alpha, we failed to reject the null hypothesis. Now, based on this, how would we make our statement? Okay, so at the 5% level of significance, because that's what level of significance we used on our test, did you say there is or there is not enough evidence? What do you think? Okay, because the claim is actually at the alternative hypothesis. So if we fail to reject this, that means there is not enough evidence to what? To support, good, got to support the HA, to support the claim that the mean is different from 22.5.
We never told the calculator we were using much outside. We don't need to. Yes, that's
Oh, no, because what we're doing is just getting the p-value and then we compare it to the 0.05. So yeah, the calculator doesn't even know that. It's just going to tell me what's the probability that I'd be in that tail. I know, it's been a long semester, hasn't it? Okay. The good news is we are just darn near done. Okay. So here we go. Let's make sure we got this right now. I'm glad you caught that, Rodney. That was our alpha. This would have been what the z-value is if we had done the conversion so we could come up with a test statistic, which would have meant that using that z-value, we would have only had half of the 0.0836 that the calculator told us in that tail, and that's why you double it to get that. But the calculator made the adjustment for us because it was a two-tailed test. And there's our statement. Okay? Now, I'm not going to give you any questions like these. I'm just going to mention, just like when we worked back in the beginning of chapter 5, that there was the option to look at z-scores on our normal curve as opposed to our areas. This is simply saying you could also choose a z-score that goes with the alpha and you could compare z-scores. Why do it another way when we know how to do it with P? So we're not going to do this. This is just letting you know that it's possible to make the comparison using z-scores. Okay? So you would just then be comparing to see if you're in the rejection region or not. But we've already got a system that's working for us.
We're not, like the last 2 pages on doing rejection.
So we're not going to do those, okay? This is just saying, you know, would you be in the rejection region, which would mean, are you on the other side of whatever that z-score is, okay? But we're going to be doing this with p-scores and just using alpha. And we're done!